Right. I present you Nate Zupan, and he was a geek since he was able to be work, and he talk about fast test.
Hey all. So yeah, as many of you know, I'm Nate. I'm from Slovenia, but I spend my winters in the Canary Islands doing any type of surfing: windsurfing, stand-up paddle surfing, boogie boarding, foiling, winging, whatever gets me on the water. But when I'm not doing that, primarily I am a geek. I've been in Plone community since around 2008. Plone Conf in Budapest was my first one. And my biggest contribution to Plone is probably the Plone API, which has since been merged into Core years back. Thank you. And since then, I've been mostly active in the Pyramid, trying to bring Pyramid closer to the Plone community. And I also built an API package for Pyramid as well. So these days, if you want to build a robust REST API with Pyramid, this is the package you should check out. The other thing that I've been super active in Plone are sprints. I've organized 20 to 30 sprints probably in the past 15 years, anywhere from the Balkans up to the north of Finland. This is a picture from a sauna sprint. We're sprinting in a sauna, yes. It was fun. Speaking of sprints, there's a sprint I'm organizing in Lanzarote in November. The topic is going to be Nix/NixOS. Some of you already use Nix and might be interested. That's why the slide is here. We have this really nice villa in Lanzarote, and I'm organizing sprints there, and I'd love to have a Plone sprint. Like, I don't do any Plone these days, but I can organize and get everything together. You just come up with a topic and someone to cover the catering, and that's it. I can organize it. So let's talk about that. Let's get you guys to Lanzarote. Right, before we begin, these are not my pants. The owner kindly already brought my pants back, so yay! Win! But yeah, to get to the meat of what I'm trying to talk about today is, for the last year, I've been developing a macOS app that checks for basic security on your device. It lives up there in your menu bar and then yells at you if you don't have disk encryption, if your firewall disabled. And then it sends this, in a team setting, it sends this data to a web dashboard where as a team admin, you can see that everybody in your team has this installed and all the checks are passing. It's a very simple Pyramid application. And I was focusing on marketing for a few months of this app and didn't do any development and didn't really review the pull requests. And I came back after a couple of weeks, a couple of months, and I saw that the tests were running for 3 minutes, and I completely flipped out. Because we only have like 300 tests, and like 3 minutes for 300 tests is just way too slow. And I was looking at why are the tests slow, and it was just the really basic things that I implicitly have in my mind, but I didn't really realize that maybe other people in my team didn't have. So I started writing up an internal document, what to check if your tests are slow. And then realized, well, this is actually a good talk subject. And just around that time, the call for proposals for PloneConf came up, and I submitted, and here we are. First, I want to get you excited that you want to invest time into trying to make your tests faster. So here's some anecdata. There's a person that increased their runtime for 50%. There's another person that's like 75% increase, or decrease, sorry, so decrease in time, increase in speed. Another one, more than half. A third, half decrease. And it's also found someone that, I'm going to give you 9 to 10 items or steps you can try today. And this team just did one of them and got an 82% decrease in speed time. It's crazy. Let's imagine that a 30 to 50% speed increase is possible without too much of an investment, like with a couple of hours. That means you're saving a lot of money on your CI, because every minute that you're running your CI, it's direct dollars or euros, so you're saving money directly. You have much faster deployments because faster CI means faster deployment, means your customers get bug fixes faster, features faster. When you have a problem and you need to like do a couple of quick deployments because something's wrong in production, the roof is on fire, it's way nicer to have faster deployments and not to wait for 5, 10, 15 minutes until the fix comes up and you're like, oh, is it gonna fix it? Is it gonna fix it? And when you're doing local development, if you have a faster iteration time, you're more productive. It's very simple. And finally, it's just this. I hate when people are just waiting for stuff to happen and are not productive. And this is definitely the case for me. If I know that the CI is going to take 15 minutes, I'm just going to start browsing YouTube, and then half an hour later, I'm going to be like, what was I doing? Because 15 minutes is enough that I'm not going to stare into a wall and wait for 15 minutes, and it's also not enough to start something meaningful, so I'm just going to start browsing the internet and just completely lose track of my thought. So ideally for me, CI should be 2 to 3 minutes, maybe up to 5. If it's over 5, then I already start acting on it. I've already talked about this with a couple of you in these last 2 days, and this is the usual excuse, but I don't have time to make more time for me. And I can give you the usual, anecdotes and quotes on, if Abraham Lincoln said, if you give me an hour to chop down a tree, I will spend the first 45 minutes sharpening the axe. And there's truth to that. But instead, I want to convince you that speeding up tests is actually easy, and it's also fun to do because you get immediate results. And speaking of coming back to Plone API, I think the biggest reason why Plone API was so successful was because it has amazing documentation. And let's see if we can fix slow tests by having amazing documentation too. Like I said, I'm going to give you a list of a number of things you can try. You don't have to take photos during the talk, because I'm going to have the last slide, all the links there, and you just do the last slide, and that's it. I see Eriko recognizes the location of this photo. So we're going to talk about how to run your tests versus how to write your tests. But before we do, I know that a lot of you want to just get your hands dirty and just start applying all the fixes and then have an amazingly fast test suite, but I urge you to don't do that. Go one by one, change just one thing, measure it locally, measure it in your CI. If there's a difference, push it to a main or master, and then wait for a few days. Maybe some test breaks for someone else, maybe it doesn't work for someone else. And if a few days everything's still as it should be, do another thing, and then just rinse and repeat. Don't do everything at the same time. Obviously, you can measure the full suite, how long it takes. For this, I suggest, is it running yet? There we go. Hyperfine, which is a super nice CLI benchmarking tool. You give it a command. Basically, you can give it 2 commands, and it's going to run either of the 2 and then compare them and then tell you if there's a statistical significant difference between one or the other. It's super nice. It has this nice progress bar and just, hyperfine, amazing, use it. And then if you want to drill down to more on a test-by-test case, if you're using PyTest, you just give it a -- durations and a number. It's going to print out the 10 slowest tests. And so you always want to start fixing the slowest test, of course, because if you have 10 slow tests and 1,000 really fast tests, you want to fix the slow tests. Otherwise, you're not gaining anything. And then moving forward, maybe at some point you're also going to get to the profiling stage. Again, with PyTest, which is what I use these days, and it's like the most common PyTest testing runner in Python. You get this nice profiling integration. So for every test, it gives you the exact call count of all the functions and sub-functions that the test calls and the code under the test calls, and also gives you this nice graph so you can visualize where time is spent in your tests. But that's, it's very specific to a product. So profiling, it's hard to talk about it in a general sense. You have to, see for each code base, what applies. So I'm just going to give you a bunch of pointers, and then you just go through them and see which one apply for your code base. Right? We're now actually going back to, like I said, how do you run your tests? First, just throw money at the problem. Modern CPUs, Macs, Intels are super fast. Make sure that everybody on our team has like up-to-date computer, laptop, whatever they have. If you can buy bigger, bigger machines on the CI, bigger images, bigger runners on the CI, or if you can afford that, maybe think about self-hosted runners. Circle CI and GitHub Actions allow you to run the actions on your local hardware device. And a Mac Mini costs like, I don't know, below 1,000 euros, and it's super, super crazy fast. And if you have one or two of those as a CI runner, it's going to be much faster than using some virtual CPU in the cloud. Right, with that out of the way, just hardware needs to be there. The first step of running a test suite is finding out which test need to be run. And this is a super important step, because even if you just run 1 or 3 tests, this will still do. Like, this collection of tests will still happen every time you run tests. And if this takes 10 seconds, meaning even if you run a test that usually takes like a second, you're still going to wait 10 seconds for the collection to happen. And in PyTest, it's very easy to check if collection is fast or not, because you can give it a collect-only flag, and it's just going to do the collection. And if it finishes in a second, you're like, OK, good. If it takes a few seconds, or 10, 15, 20 seconds, like, OK, this is where we have a problem. Sorry?
It's a bad smell.
Yeah, bad smell. Yeah. Yeah. And my ballpark figure is around a second. It should take a second for 1,000 tests. If it takes more, that's probably something in there that we can improve. And usually the culprit is that you're pointing PyTest at too big of a directory tree, and then it scans so many files, and that's why it's slow. And you can, with this configuration, you can tell it, don't look at .git, don't look at this tox file, don't look at this large machine learning model that we have here. Or alternatively, you can say PyTest, just scan this really specific tests directory, which sometimes is not possible if you have tests split out into different folders. That's when you use the first approach. Another common problem with the collection is the collection also runs conftest.py, which defines your fixtures in PyTest, and also imports all the modules. So you might have big top-level imports. For example, if you import machine learning models or libraries, or Django or Plone as a top-level import in your tests, that's gonna happen during test collection. And if that import is slow, your test collection is gonna be slow. To figure out if this is the case for you, you give it a -- no conf test, so it's not going to run the conf test, not going to do the import. And if there's a big difference between collect only and then collect only with this no conf test, if there's a difference, that means the problem is in the conf test file. And there's also a tip there how to visualize the import time. For example, here you can see that I had problems with LXML. So one test had a top-level import of LXML, and that slowed down our tests. The solution is simple. You just move the import into the test function. And so the import will get run when the test function runs, not when tests are collected. So yeah, very easy fix. Another easy fix is to prevent Python to generate bytecode, because you don't need that in development, and you almost surely don't need that in CI, because you're always starting with a fresh system, and why would you prepare this cache if you're never going to use it? It's not going to give you a huge amount of improvement, but anecdotally, I know people that this really helped for them, especially people that use maybe network drives and maybe a bit more complex CI systems. PyTest comes with 30 built-in plugins, and potentially you don't need all of them. You list them with traceconfig, and then you disable them with this -p no colon. I usually disable doctest, nose, and pastebin plugins, because I just never use them. So why load them every time I run PyTest? Right, so collection is now sorted. All our tests are collected super fast. And it's time we get a bit picky. By this, I mean, usually we have some tests in our test suite for which we know that they're slow. And maybe it doesn't make sense to run them every time on your local machine. So you can mark them as this test is slow, it's not going to get run. And then in CI, you can say run all tests, including the slow tests. So this is just a small improvement for the iteration speed for your local development. You can be a bit smarter and use PyTest incremental, which looks at Git diffs to determine what tests need to run based on what you change in the GIF file. Or you can use PyTest testmon, which goes a step further, which checks, because it checks the coverage report to see, so these 5 tests touch this line in your code, because that's, you see it in the coverage report. So we need to run these 5 tests because this line was changed. So it picks up even more tests than PyTest incremental, but it's a bit more involved to set up because you need to save the coverage report from the previous file so that this tool can work with, has some data to work with. And this can also be used in CI. For example, you can do incremental testing with these 2 tools for branches, and then just do the full suite for the main branch. Or you could do the incremental run first, and if that passes, then do the full test, and maybe you save some CPU credits on the CI with that, because you never run a long test until you check the things that you've changed. Right. So we now know how to run our tests. Let's see how we should write our tests. Unit tests rarely need to access the internet. Usually what we do is we mock all the requests to the internet so that we can test the various different responses and failure modes, and also to make them fast, because the tests are not actually waiting for responses. They just get them because they're mocked. However, we often don't realize that the code that that's being used under the tests is doing some network connections. For example, what happens to us specifically was we added support for gravatar profiles, and those were added into the main endpoint for the user. And like user endpoint is called basically on every page because you need to display the the username and the profile, and that meant that the majority of our tests now started to push requests to Gravatar to get to the Gravatar API to get the profile URL or whatever, and we didn't realize that, and we had this, our test case got slower by this. Like it was 10% slower for me locally on a really fast internet. If I would be somewhere on a conference, like this would be super slow. And by using PyTest socket, these tests started failing because they failed with internet access was prevented, and then I realized, oh wow, yeah, we're not mocking the Gravatar requests. Let's mock them. We mock them. You have safer tests, more robust, and faster. So PyTest socket, very nice to use. Similar to network access, I would also say that disk access should very rarely be done in tests, because it's error prone, and also again it's slow. Disks are slow. They're faster than network, but they're still slow. And one option is that you mock everywhere in your test code where you have open file pointers or whatever, or you can use PyFakeFS, which builds you a in-memory file system. It can also take actual files, map actual files from your file system, but it will never write the changes back. So again, it's safe because you're not touching the real file system. It's more robust because you're not taking context from the current file system, and potentially then tests break in CI or for someone else. And it's faster because it's an in-memory file system. It's not accessing your disk. So maybe on CI, if you don't have SSDs, like this would be a really big speed improvement. Yeah, cool to use. And then we go to databases. These days, if you're testing a real-world web app, you usually have a database access in your test. So we're not really writing unit tests, we're mostly writing integration tests. But still, some tests might not require a database. If you're testing a function that calculates an age of a user, you don't have to fetch the date of birth from the database. You can just provide it to like a hard-coded value to the test function, and then that test doesn't have to set up a database. So you probably can set up your test suite in a way, or your test cases, your test fixtures in a way where you have tests that do require a database, and then there are tests that don't require a database, and they can run faster. So that's the first approach. To speed it up. The second one is maybe not all tests require the entire database. If you're just testing user profiles, maybe you just need the tables and the data for the user profiles and the related tables, not everything else that you have. You can ask yourself, can you create the database only once? When people start testing, they usually create, populate, and destroy the database for every test. So if you have 100 tests, you do 100 times the creation, destroy, creation, destroy. And probably you can create just once, and then at the end of the test, you truncate all tables, which means you empty the data of all the tables. Truncate is a fast operation, so this happens much faster than create, destroy, create, destroy. So you create, and then truncate, truncate, truncate after every test. To be even faster, you can make sure that your tests never commit. I'm doing this, and I like the approach. So you create a database once, you populate it with some dummy database, and then you run your test, and in the end of the test, you just roll back. So you never commit the transaction. Sometimes you still need to, because for example, you have to test something where the commit is necessary. So this is a bit more involved, because you have to remember that whenever you do a commit, you then have to manually revert the data that you committed. But for us, maybe there's like 1 or 2% of the tests that are like that, and the rest of the tests can use this rollback mechanism, which is way faster than truncating and repopulating on every test run. So a couple of approaches. Right, we've covered both, but there's more. There's one part where you actually have to combine both, and that's parallelization. This is where the big wins are. So if you want to have really, really fast CI, you need to look in parallelization, but it's a bit more involved and takes a bit more time. So definitely starts with other things first. In the PyTest world, this is the de facto tool, PyTest XDist. It allows you to split your test into multiple CPUs, multiple sandbox subprocesses, even remote workers. The problem is it usually doesn't work out of the box with real-world web apps where there's very complex fixtures and tight integration with databases. The main reason is because PyTest basically runs the test setup on every worker, and then you get database conflicts, and the workers don't have synchronization between them. So again, if you're doing the populate and truncate and populate and truncate, and there's 2 tests running simultaneously, and one truncates while the other test is still running, it's just going to fail. PyTest Django works around that by creating a database for each worker and then suffixing the database name with the worker name. So that's one possible solution. It takes a bit more memory because you need to spin up, if you have 5 workers, 5 databases, but it still runs faster compared to running the entire suite serially. Yeah.
And the same for the file system.
The same for the file system, yeah. Yeah, exactly. Yeah. PyTest Split is potentially a better first try. It's much easier to start. Usually you don't need to change anything in your code base. The drawback is it doesn't help on your local development, so this is only for the CI. What it does is it keeps the durations of all the tests in a file, and then it looks into that file to decide how to split the test into similarly sized chunks based on the duration. So it's not like alphabetically, but it's based on the previous run duration. And then if you tell it, I want to have 5 workers, you just tell PySplit, I have 5 workers, and it's going to split them in your CI. And then you have to make sure that, so this is more of a DevOps task than it's a developer task, because you need to configure CI correctly to run these 5 workers, and then save the coverage for every worker, and then have another CI step at the end to combine and to merge the coverage report, and then run your total coverage at the end, and maybe fail the build if it's not 100%. So yeah, I like this one a lot, because it doesn't matter how legacy and poorly built your test suite is, you can probably split it with this. With PyTest XDist, yeah, potentially a lot of work, but with this should be fast. Now that your tests are fast, how do you keep them fast? Because this was why I even started this talk, if you remember. The tests were fast. I didn't work on the project for a few months. I came back and they were twice as slow, or 3 times as slow. So my answer is this. I created a GitHub application that will, for every pull request, measure or check if the test got slower or not, and then will annoy you, or even block the merging of a pull request, saying like, your tests have gotten slower. You just go on GitHub, click install. There's very short installation procedure. Basically, you just tell PyTest to dump the test durations into a CSV file, and then you upload the CSV file for the app to use. And yeah, like I said, you get a comment like this into every pull request. At the moment, I support PyTest and GitHub Actions, but it should be quite trivial to support Plone as well, because Plone uses Jenkins, and Jenkins has JUnit output, right? And JUnit has the time duration the test duration.
The ZOP test, right?
Yeah, that's what I meant. Yeah, sorry. So it's if there's any interest, I would be very glad to support this. And yeah, the app is free for personal use and for open source, and I'm also absolutely making it free for the Flow Foundation. So let's get this. Yeah, check it out and let me know what's missing. Yeah, one more thing. At the moment, I'm just measuring this full suite duration, but in the future, I already have ideas how to also measure CPU cycles and memory consumption, and then I'm thinking that it's probably a good idea to say that like if you add 5 tests and those tests are in the like 10 slowest tests, also to make them visual. So there's it's gonna grow a bit. It's a bit basic now, but it already works. Like we've been using it in our company for about a month now, and it's already catching test performance regressions. So it's definitely usable. A few extra tips because we have time. For local development, I suggest using last failed. So you run a test suite, 3 tests fails, and with this, the PyTest will run just the failed tests. So again, your iteration is faster. And there's 5, 6 PyTest plugins that I use in every project, and I've listed them on that blog post, so you can take a look later. And yeah, like I said, find this repo. It's called Awesome PyTest Speedup. There's a checklist there. You can just copy paste into your own ticketing system and then just go one by one, just one a week or one a month or 2 hours a month. Go through them. Those are all links to descriptions how to use them in more details. There's some general guidelines like how to measure stuff and some extra tips at the end. And yeah, very open to pull requests and comments. And also I'm potentially considering doing a bit of consulting for this, because it's exciting to me helping people be more productive, and it's also I see it as a climate conscious action, because if we're saving CPU executions in the cloud, that's definitely saving some carbon emissions. So yeah, if you'd like some help with applying these techniques today, let me know and we're going to have a chat. That'll be all.
Have you any questions?
I was there yesterday and how did that work? Yeah. So I was not there yesterday and the day before, so I don't know if it was mentioned, but your talk is about PyTest, which most of the Plone community does not use, even though they should. So there's a plugin. I mean, there's an egg that enables you to run the whole Plone test suite with PyTest, so you can reuse all nice hints from nets with Plone as well.
As David said yesterday, yeah, there are a number of Plone add-ons that are already tested with PyTest, and there's a fixture from GoSept that allows you to run. Oh yeah, okay. Yeah, so there's definitely, as far as I would say that there is definitely movement towards PyTest in the Plone community. But everyone that's doing Plone is also doing other stuff like Pyramid and other frameworks, and you probably use PyTest there. So,
well, I'd say it's maybe early days for using. Not a lot of projects are using it. If you try it and have problems, don't give up. Post about it in community, and we'll discuss how to make it work.
Yeah. Any more questions?
Okay, it's time.
Cool.
Thanks, Nate.